Hi everyone, let me begin this video by introducing myself. I am Mushnaq Kothari. I'm a qualified fellow actuary. I have been professionally teaching actuarial science for the past 8.5 years and have overall actuarial experience of 8.5 years as well, along different verticals in actuarial. So that was a brief introduction regarding me. Before we get started with the solution discussion video, I just wanted to let you all know that the new batches for IFoA April 2025 session is starting off 6th of October, even for ones who are not appearing from II in the November term and are planning to start with their exams from II May 2025 session. The batches are starting from 6th of October itself. Do note that at Finatics, we hold one single batch itself for the entire term, be it for IAI and IFOA. Obviously, we have kept in mind that IA exams will be getting over in November, so we would be, scheduling our classes accordingly so that once who join us later, who is giving their IA exams in November, they can also continue with our batch itself. Do keep in mind we have limited intakes for our live batches, so it's important that if you're looking forward to getting full services from us in terms of live classes, doubt clearing, ample time from the faculty, the earlier you join, the better. We would be holding classes in live offline format in Calcutta, live online classes, as well as pre-recorded lectures. So from wherever you might be, any state in India or outside India, it doesn't matter. You would be getting access to all the classes along with proper doubt clearing support right from day one itself. So it's not that you would be left to spend, clear your doubts yourself and you would have to post them in a particular forum where the faculty might or might not, answer it. All the doubts here at Fanatics is taken by me and my colleague Gunjan itself. So we both of us are qualified fellow actuaries, credentiated as well. That is, we are allowed to use FIA credentials from IFoA. So whatever doubts you have, these would be resolved by us, not by any other junior faculty. We believe that doubt clearing is one of the most important aspects of classes, and that is something which should be left for the experts itself and not to others who might be able to help maybe in certain basic doubts, but not for the more complicated ones. So that's something regarding our classes, and I firmly believe I even others around who are similar minded along with my colleague that it is very important for students to start with the preparation very early on, so that they have buffer time later on. In case of any externalities or anything negative or anything uncontrollable, there's a buffer time so that their preparation is not hampered. So to motivate or to incentivize our students to start preparing early, maybe take a couple of days or a week's break after examinations have got over in the September term, but don't delay it further. I mean, if you have signed up with actuarial science, exams are going to be a part of life. If you enjoy it, you should anyway get started with it very soon so that you can enjoy more. If you don't enjoy it, the sooner you can get something off which you don't enjoy is better. So in whichever way you bring it, I'll always have reasons, to incentivize you all to join early on, because that just makes logical sense to me and should be the case which I feel most should be following. So as part of that, we would be offering early bird offers for students who are enrolling between 15th to 30th September. These would be on a first come, first served basis only, since we have a single batch and a limited intake. So all these offers are till the time we have seats available for the live batches. Beyond that, I mean, one can any day enroll for the video batches at any point of the year. But beyond a particular capacity, we would be enrolling more students for a batch, to ensure that all our students get sufficient time from the main faculties itself. So we would be multiple offers in terms of maybe flat reduction in fees of certain papers, combo fees, so on. So for those details, you can drop us a WhatsApp message and further discussion regarding that can be made. So that's what all from my end. Hope the solution discussion video is helpful to you all. So overall, the first set of commentary on how CS2 paper A was, this was slightly different from the last let's say 4 5 terms where the paper, the students have found the papers to be more difficult. But this paper, at least for ones who are moderately well prepared to well prepared, they would have found this paper pretty scoring. There were 8 questions. There were certain pockets where students did tend to struggle, but the ones who were well prepared, they did not make such silly mistakes. So in terms of passing marks and keeping in mind how paper B also went, I foresee it to be somewhere between, let's say, 54 to 58. Um, Next thing is, in case you do find any sort of calculation errors or you do not agree to the solutions provided and have any alternative set of solutions, do let us know to the comments section. We'll take a look into it. And in case we find merit in it, we would be pushing in the rectifications through the comments section itself. So at whatever point of time you are looking at this video, make sure to take a look at the comments section as well, just to see in case there are any corrections or not. And definitely do like this video in case you find it useful, and do share it among your peers as well who might have prepared for CS2 or in future might be preparing for CS2 subject. Getting started with the paper. First question, 11 marks. This was one of the most straightforward questions. I was going through the script of one of the candidates, and it was really disappointing to see a very, very silly mistake being made where, over here the retention is mentioned to be 12,000. So when we have these three claims of 12,000, these are the net claims. So obviously the gross amount or the actual claim amount would be more than this. So these three correspond to censored data, and we do not have complete information about it. All we know is that it is more than 12,000. That was one error I saw in a script, and it was very disappointing because, in CS2, you don't get the bandwidth to commit such mistakes. There are very few direct questions which students find easier. And in case you make errors in those, then it's very difficult, to score sufficient marks to clear the examination. One more thing, I do think that this particular video is going to be slightly longer as compared to other solution discussion videos. Maybe it takes 15 minutes or so for other subjects. I foresee right now it might take 25-30 minutes because I do want to add commentaries to each and every question. The couple of scripts which I saw, I mean, most of the questions had some or the other error, and it was very disappointing to see students making such sort of silly errors. Already we had this question from mortality projection of around 15 odd marks, more theoretical in nature, and a lot of students who did not had complete their syllabus, they tend to leave this and another, let's say, machine learning chapter. So they did leave that question. So it's like there would be 1-2 questions of 20-30 marks in total, which are going to leave. So you need to make sure that you have a very high level of accuracy for the other questions to stand a reasonable chance of, scoring well in paper A. I mean, scoring not well, but scoring sufficient enough in paper A so as to clear CS2 paper. So let's take a look at the solution. There are 9 data, lambda to the power 9, e to the power minus lambda summation xi, and the three claims are more than 12,000. Solving it, I was getting lambda hat as 3 by 40,480. Now, on the second part, it was mentioned that there's a current reinsurance treaty in place. Whatever is the expected claim amount from that or the mean claim amount, it should be same as that. Post a proportional reinsurance arrangement has also been made. So first thing is we need to find the expected mean amount under the existing excess of loss reinsurance structure. Now, I have not shown the steps of derivation. This is something you can refer to, let's say, the acted material as well. The similar question for exponential distribution calculation of mean under XOL reinsurance is given there. So you can take a look at there as well. So the results come out in the form of 1 by lambda 1 minus e to the power minus lambda m, and it comes out as 7948.49. This we need to equate with alpha expectation x, which is my expected mean amount under proportional reinsurance. And on solving, I was getting lambda as 58.91%, rounded up to 2 decimal places. So this should have been one of the most scoring questions, but a certain common errors was, not considering this. Now, for some of you who might have the question that who have incorrectly estimated the parameter of lambda in part one, will the marks be penalized in part two as well? My understanding is no, you would be getting due step marks. IFoA does categorically mention, and even interacting with a lot of my peers who might be involved in examination team and they are marking. So they do discuss that they are given, there is a statement usually in most of the scripts where you do not want to double penalize for the same mistake. So if there's an incorrect value of lambda, obviously in second part all the things on numerical values will be different. But if all your steps are correct, forget, let's say, the numerical value, due marks should be there. Now, whether it should be full 7, 5, 6, that depends, maybe paper to paper and on the guidelines set by the chief examiner. But a good proportion of marks would be there, and there should not be a dual penalty of same. Next question, to again a very, very straightforward question, I would say. I mean, If anyone looks at the paper and they look at the first two questions, it should really set up them for a very good mood. 22 marks, very scoring. Even if I ignore the last 2 marks of comments where some of you tend to struggle, still 20 marks, very straightforward, relatively short, not much complication as such. So if I look at the solution for part 2, 20p0 is 0.25, 25p0 is 0.2, and then applying consistency principle, I can split this similarly over here, dividing, solving, I get mu as 25 by mu as 0.044629 and 10p naught as 25 by 64. Part 2 is computing 15p72. So first, we need to compute A, B, and C. This involves solving three equations simultaneously. Now, you need to be very careful given the sort of values you're working with. Try to take it as accurate value as possible. Don't round it up till 4, 6 decimal places because the final answers for other values could be slightly different. So like initially I had rounded off C to 6 decimal places and then I calculated B and A. And now if I'm trying to satisfy these three equations, they was not being satisfied till let's around third or fourth decimal place. I was not happy with that. I thought no, it should not be such a difference. I mean, it was not matching probably even in the second decimal place for one of the equations. So I took the exact values and then I double checked. So, you will see that is why I've scratched out the values of B and A. Just I would have recalculated using the accurate values. So these were the values which I'm getting of A, B, and C. And 15p72 I was getting as 0.000382976. Part 3 is comments, validity about the force of mortality. So, if we'll take the force of mortality and, calculate over here, let's say e to the power 15 mu, and that value is lot more higher than this. So clearly the forces of mortality are not constant above age 10, and which makes sense also. So this is what online you could comment on it. Question number 3 from time series, relatively, I would say again very, very straightforward, but I was very disappointed to see the solution for second part specifically, the autocoherence function. I mean, it should have been straightforward to see, if not straightforward, I mean, for once I've practiced well, they know covariance of, gamma 1, gamma 2, 3, 4, 5, 6 should be 0. This is the AR process. There is no dependency at those lags. But somehow you all did not solve the simultaneous equation. Had you solved it, you would have got it as 0. It would have been, I would say that straightforward. So it's like I have not got any script where I have been able to cross-check all my solutions yet. So I'm still wondering, and it took me maybe what I guess odd 75, 80 odd minutes to complete this. I had not done question 7. That was more on, theoretical bookwork, but other questions, the numerical part, took me 75, 80 odd minutes to do it. Obviously, this was on paper. If I was doing it on what it would have been taken more. But still, I mean, this was, I mean, for well-prepared students, this was a way easier paper. For ones not, they would have made certain silly mistakes and so on. So coming to question 3, mm, okay, I guess I have forgotten to consider the image of question 3. I guess that has happened. So let me now discuss the solution. So identify the values of A7. So mod A7 must be less than 1. Derive the autocovariance function. So over here we'll see that it will be a non-zero value when k is a multiple of 7. So gamma naught will be sigma square by 1 minus a7 square, and gamma 1, 2, 3, 4, 5, 6 will be 0. Similarly, 8, 9, 10, 11, 12, 13 will be 0. And when it in terms of multiple of 7, then it, if I remember correctly, it was a7 to the power k by 7 sigma square. So if k is 7, then it becomes a7 to the power 7 by 7, which is 1. So it was becoming a7 sigma square. Similarly, gamma 14 was coming out as a7 square sigma square and so on. Part 3, comment with reference. It's on commenting part on the suitability of, of the process for modeling seasonal data. Now there is a seasonal aspect coming in terms of, after every 7 lakh. Part 4, specify the values of A7 for which seasonal difference is applicable. Now over here also, the moment we say seasonal differencing, I mean, we should get somewhat a factor of 1 minus b. Now if you take A7 as 1, you would be getting a factor of 1 minus b because it will be 1 minus b to the power 7 yt. Still, some of you did. I don't know what you all did. No idea. It was disappointing, to see the scripts at least which I got. It was a very small sample, maybe 4 or 5 of you had shared the scripts before I had, prepared my solution or referred it. Some of you have shared after that, but I have not checked those. So yeah, this was also disappointing. Question number 4 again. Students struggled in part 3. I would say part 1 is like 3 marks, 2 marks, very easy. Derive the transition matrix is direct bookwork derivation. Part 3, certain derive the stationary distribution related to matrix P. So this is not Markov jump chain, it's Markov jump process. And we can calculate the stationary distribution for Markov jump process as well. Now, for ones who would have solved faster papers, especially for IA as well, there they have applied this over there. Even for ones who would have gone through the set of notes we provide. Specifically, there was a separate lecture. It was probably an optional lecture which went about, or it was a solution discussion video where I had mentioned how we calculate stationary distribution for a Markov jump process. Simply need to use the fact that pi a is equal to 0. And some of did Markov jump chain solved it. If I would have been the examiner, I would have given 0. But obviously in part 4, if I am using wrong stationary distribution probability, still 2 marks would be awarded. Even in part 4, there were certain errors. Most of you did not consider portfolio of 350 policies. You all assumed it for a single policy itself, and that was very, very disappointing. So it's like for one policy, these are the structures. It's written for each of the states, the overall claim size is this, and the policies exist in 3 possible states. So there are 350 policies which you need to incorporate when finding EPV or variance. So in terms of solution part 4, this is part 1. Part 3, even I've shown how it can come. D by dt pt is equal to pta. Now if I differentiate, or if I say it's a stationary distribution, what do we now mean by stationary distribution? This is where I say your fundamental concepts should be absolutely clear. It might have worked even if it's not clear for other papers, because they would have given same questions, but CS2 is one of those papers where your concepts needs to be very, very strong. Now stationary distribution means that even after next transition, the proportion and differentiate will not change. So therefore, d by dt of pt will be 0, because pt should be constant once the stationary distribution is achieved. So, this becomes, let's say, d by dt of pi is pi a, replacing pt by pi. So this becomes 0, and we have the equation pi equal to 0. Another very intuitive way to look at it is, now A, the generator matrix, is nothing but the forces of transition. Now my stationary distribution is where things have settled, that even after next transition, the distribution shall remain the same. So which means that the total forces affecting the particular system should be net 0. The net force should be 0, because whatever transitions happen, they would cancel out, and the stationary distribution, or that, I mean, the very sense of stationary distribution, that the proportion will be same, will be intact. So the net force on the system will be 0. So from there also you can understand why pi a should be 0. Mathematically we have derived. To the extent we can try to understand intuitively, we would do so. So pi a gives us the the net forces occurring in the system, and that should be 0 if we have already achieved the stationary distribution state. Now these are the first 3 equations coming in from pi a. This is the standard equation, a plus b plus c is equal to 1. Solving these multiple equations, it's laid down the certain steps as well, how we have gone about it, getting A as 5 by 28, B as 1 by 9, C as 39 by 56. And in the next part, what I've done is I've taken the denominator as 56 and expressed numerator accordingly, so as to just make our calculations or presentation easier. Now in part 4, what I've done is I first found out the expected value for a single policy. I was getting it as 2950 by 7. So for the portfolio, it becomes into 350, which becomes 147,500. If you're in India, you could say it to be 1,47,500. For most of the rest of the world, they work in millions and millions. So they would say this to be 147.5K. They don't have the concept of lakhs, they have a concept of millions. So make sure the commas, if you give, I would say avoid giving comma, especially if you're in India, because the way we go about giving comma is different from others. So avoid doing that. If you're doing it, make sure it's in the form of millions and billions itself. So you cannot write 1,47,500. I'm not sure if they will deduct marks or not, but many of the examiners who might not be aware, why this comma is given there, they might not be aware how the systems might work in India. Similarly, expectation x square is coming out as 192500. Now, variance of one policy I've calculated, so I've done standard deviation. Now, there are 350 policies, and note that these are, for each policy, the state is this. So, if you want to work at the portfolio level, it will be like either once you have a proportional distribution, So the number of policies in 200 will be, proportion of that into 350 and so on. So it's not that independently they are cancelling out as such. It's gonna be 350 square. Another way is you just look at the amounts of portfolio. So it's going to be 350 into 200, 350 into 300, 350 into 500, and then we have individual proportions as well. So my standard deviation of portfolio will be this amount into 350 and not this amount into root 350. So, in some cases when all the policies are independent, the variance becomes n sigma square. Standard deviation becomes root n into sigma. Over here, what is going to be is n squared sigma square is the variance. So standard deviation is n into sigma. So a lot of you made mistake over here. Some of you did not even incorporate 350 part as well, just did it for a single policy. Next question number 5. This the numerical part I would say was related should have been straightforward, directly from material Clayton and as well as Gumbel. So if I talk about the numerical aspects of it, first part was derivation is book work. Second part, now again over here I was referring to a answer script of a particular student. Now the question clearly states calculate the probability that both funds fall in value over next year and the distributions are for returns. So if the value of the fund falls, it means returns are negative. So what we need is that x is less than 0 and y is less than 0. One of you I saw, I do remember the student's name. I don't want to take it, but I do saw the script and you had considered it as one. It's disappointing. You need to read the question carefully. And as I say, for giving CS2, you have very, very less places to make errors, especially if you're not very adequately prepared or if you're still struggling with your concepts. So, you need to ensure whatever things you're attempting, you're doing it absolutely right. So this is how I went about it. I calculated U, V, took the joint probability on computation. I'm getting 0.123309. Next part is both of them should be zero point 0.1. It's coming out as 0.595212. Now we'll see that the Gumbel copula has an upper tail dependence. So therefore, if one tends to give higher result, the other might also be tending to give higher values. So therefore, this probability is higher compared to this. Although if x and y was independent, both these probabilities should have been same because the mean is 5%. So it's equally likely to get less than 0% or more than 10% because these are equidistant, let's say, from the mean over here. So if it was independent, both the probabilities in part 2 and 3 should have been same, which is not happening. Now in part 5, again, here they mentioned that, they do not want to allow any dependent behavior, so they want it independent. Now again, for a Gumbel copula, if you take the parameter as alpha is 1, it just nothing but simplifies to a product copula or independent copula. That is both the distributions are independent. So you take alpha as 1, just a simple adjustment that you need to take alpha as 1 so that Gumbel 2 becomes Gumbel 1 and Gumbel 1 is nothing but product copula, which will assume portfolios X and Y to be independent in nature. And then part 6 was, theoretical bookwork regarding the advantages, disadvantages of models, where it could be used, and so on. Next question number 6. Now again, this question 9 marks. Some of you know left it. Poison process is part of life. It is there in CS1, CS2, in CM2, in higher papers. You work fundamental things you need to understand. Your stats concepts should be very, very good. Now over here also, I guess I would spend some time. Now I was wondering once I solved it, I am probably doing something wrong or what because it took me probably 2-3 minutes only to solve this question. Obviously, I've not written down the explanation over here, but I'll be discussing that. So my first of all, my answer was coming out as 0.41797. Now let's go step by step. We have been given that between time 1 and time 2 minutes, we have got one claim. We need to find the probability that between time 0 to 2, there are exactly two claims, and between time 1 to 4, there are exactly three claims. So which basically means if from time 1 to 2, we have one claim, and if I want from time 0 to 2, two claims, it means that between time 1 and 0, I have exactly one claim. And between time 4 to 2, I have exactly two claims because between 1 to 2, I have one claim. So this way I can write. Now, this is a Poisson process where the increments, non-overlapping increments are independent. So therefore, these two will be independent of n2 minus n1. Now, again, these two are non-overlapping increments. These two would also be independent. So we simply multiply the respective probabilities. So it was that easy when you look at it, but only if you understand what is Poisson process, its properties regarding to independent increments, stationarity, not whichever you want to look at it, whether you think it in forms of independent increments or whatever happens in the future time interval is independent of the past interval, whichever you want to put it, and due explanation would also be there. So maybe for these steps around 5, 6 odd marks, and the rest would be for your reasoning part. Question 7 was modality projection, kind of theoretical, so I'm not discussing that question. Question 8, the last question. Now again, Markov chain was there, but this was not that you need to create a model as such. I mean, it was pretty much given how transitions are occurring, what states are there. You just had to use your numeric abilities to compute it. Disappointing to see a lot of you. I don't know where you will spend so much time. At least the couple of scripts I saw. I mean, as this was, at least I would still maintain for well-prepared students, this was a very, very relatively easier paper, especially when I look at the past papers. All questions is something which should have been attempted and, done broadly right. Some silly mistakes, fine, but not fundamentally a lot, or, skipping the questions altogether, so on. Now, question 8, this is how I've gone about it. So from X, we can go to Y. Now, question says that once I read the question, I misread it. I thought occasionally Y throws to X. So I thought maybe X can also throw to Z, Z can also throw to, let's say, X, or let's say Y. And then I realized, there are so many variables. I don't have sufficient equation. I went back because obviously I have confidence, this question won't be there. I'm unable to solve, means something is going wrong. Went back to the question I read, it's usually X to Y, Y to Z, and let's say Z to X. Occasionally, Y throws the ball to X. All three throw to themselves, but let's say X cannot throw to Z, Z cannot throw to Y, and only Y can sometimes misthrow it to R. X and Z cannot. So obviously, this makes a lot of one-step transition probability is 0. So this is what I have, the one-step transition probabilities. Now in the two-step one, I have not computed the entire two-step, only the ones which have been given numerical values. I've computed using p square, not shown the steps, but you can calculate it. It should be coming in this form only. So these are the 4 equations. Now the first one which we can solve is, let's say, the last one. From here I am getting d as 0.25. I can also solve the second equation and I'll get the value of c. Now there will be two values. C should be lying between 0 to 1 only. So 1 would be negative value which we can discard. And then by substituting the value of d over here, I get the value of a. And by substituting the value of a over here, I get the value of b. And the other values similarly. So I was getting a as 0.5, b as 0.3, d as 0.25, c was 0.0916. Next part, the probability is that if Z currently has the ball, Z will have it again after exactly 4 subsequent throws. So what I mean is that Z will next, for the first time, will have it exactly after 4 throws. So it's not that Z got it in 3 throws or 2 throws. The first time it's getting again is exactly after 4 throws. That is my interpretation. So these are the ways: Z to X, X to Y, Y to Z, Z to X, X to Y to Y, and Y to Z. So adding this up, I was getting probability as 0.1076868. Part 3, state with a reason if the Markov chain is irreducible. No, it is not. Once you go to state R, it's over. It's an absorbing state, so it is not irreducible. And next is state the stationary probability distribution. Now, for a chain which has an absorbing state, the stationary distribution, if there is, let's say, one absorbing state only, so all the other states will be 0 and that state will be 1. So even if the marks is given 1, so even if you don't know part 3, because part 4 is 1 mark, and stationary distribution takes time to calculate. But if it is a 1 mark, means it should be somewhat straightforward, either 0, 1, half, symmetrical, this scenario only. So means part 3 also should ideally be not irreducible. Because if it is irreducible, we can move from any state to another state, and that will lead to a stationary distribution where there will be a lot of non-zero terms. So these are the various ways where you connect things, you make sense check. And again, this is not restricted to exam. Once you start working, you do your own business or whatever you're doing, you observe, you try to see pattern, you make sense check, you compute one and then you try to make sense. What if something had differed, what my answer would have been now, whether it makes sense or not. So for example, if two things are independent, the probability of it happening would be lesser than if those two things are dependent. So if I don't know, if I'm getting a dependent probability as, let's say, 30%, and if I get independent as 40%, means something incorrect I might have done. If the independent is less than 30%, yeah, it makes sense. Again, directionally speaking. So there are a lot of things which you can see, observe, correlate to sense check your answers. And it's a very, very important tool. I mean, for exams, it's there. Even if you do not apply it, you might still clear it. But once you start working in a corporate setup, or even if you're running your own business, or doing even a non-actual job, the ability to sense check, identify, observe patterns, and that will only come if you have somewhat an interest, and more so you just look at numbers, you try to picturize it, not just doing it blanketly, you're just solving it. You try to understand what is being done, what is being asked, what are the different ways of doing it, how you can touch upon other concepts, and so on. And this is what a true actuary wants. Given what both the actual bodies are doing, you will see, so many students coming in clearing papers, but that filtration which was previously there by virtue of the difficulty of exams, that is kind of diminishing with all actual bodies trying to get more and more students. I mean, it's utter nonsense which I see. So there would be sense of dilution where, clearing all exams will be just sort of a necessity, and it will not be a filtration, which at least I feel was there in the past, where if somebody is clearing not many papers, especially the higher papers qualifying, it was an automatic filter. But now it's like anyone who is not that able compared to someone else who would have cleared the papers 10, 15 years back, that sort of distinction has gone. And you can just compare the past percentages. 10, 20, 30 years, take any actual body, IFoA, II, maybe other bodies, look at the proportion of students clearing. Once I've had a talk with a couple of very senior actuaries, 8, 60, 70 plus, they used to say, 10% of the students used to clear examinations at that time. Now we have some papers 40%, 50%, even sometimes 70, 75% clearing it. And it's consistently, and when I look at the questions, it's way more easier than what we're doing today, than what we were doing earlier. So what it happens is it attracts more crowd, more people will do, and then, a company will see there will, for one role, there might be 10 people or 10 candidates applying, all having, let's say, 8, 9, 10 papers cleared as fresher jobs. That papers will no more go away. Now that will just become a bare minimum criteria. Yes, you should be having so many so papers cleared. It's not a very big thing to have it because the system has made it easier for you to clear it. Again, that is not to, scare you or demotivate you. It is just that for, ones who are very, very, let's say, enthusiastic about actuaries, intellectually very capable, very hardworking, and all thought, just by clearing papers, you can announce you are there in the world in actual profession. That will somewhat reduce. So, I mean, we all face that. Previously, we used to clear papers, there was some sorts of distinguishment. Now we know how students are clearing papers. Examination systems are also easier. There is a lot of mess as well in the terms of, the way exams are being conducted and its credibility, be it from IFA and now even with II bringing this home-based exam and MCQs, even the proctor. I mean, I know how students can get over it, and they have been doing so. II is in complete denial about that, and sometimes I feel, just to challenge them, I will bring 20 students. They'll keep their phone on. They will score 100 marks, or let's say 90, 95 in paper, and you will have no idea whether they have done it themselves or not. Because practically you can't determine if somebody keeps a mobile on the screen, I will not know it. Seriously, they won't know it because I know students who have done it. They don't talk to me openly about it because they know how I am and I might report it. But it comes out to my ears what students are doing, and then when I'm teaching some student, I know they've not studied and still they're clearing it. I know it's not through conventional tools. So it, more than anything, it impacts the ones who are studying in a fair way because they will feel aggrieved. So hopefully sometimes better sense prevails on the senior management of both IA and IFOA. And instead of trying to attract more students, I don't know, maybe produce more actuaries, earn more money through membership fees, exam fees, focus should be on having a proper examination system where it's not about clearing more students. It's about the consistency of papers should be even. Obviously, some variation would be there in certain terms. Some term the paper might be relatively easier. Let's say out of 100, 30 students might clear, and some term it might be 20. But it should not be that you just want to make everyone clear the exam by making the papers absolutely easier. It will just dilute the entire essence of the filtration which this profession had. So anyway, that was a kind of a detour, but I mean, this paper is an opportunity for you all to know that it's very important to have your concept strong, be in a position to apply it to various new areas, not just academic, actual papers, day-to-day life, or investment decisions, behavioral decisions, how you communicate to others, whether you're running your own business, whether you're doing an actual job, whether you're doing a non-actual job, any sphere. I mean, the subjects provide you a tool. It's up to an individual how they apply it. So that's it. Thank you.